going to go all the way down the value chain into the antenna, and we're going to learn a bit about that and how we can use that to our advantage. So we have the CEO of Ignion, who's going to be up here on stage and who's going to be presenting about that. I'm really looking forward to that. Please put your hands together for the one and only Jaap Groot.
Thank you. Thank you very much, and a warm welcome to everybody. As just said, I think what I just heard was a great explanation why we should be doing IoT, at least partially. We are in the market, in the cellar of the market, to make it happen with all you guys on the wall of fame behind us with antennas. So that can be very boring. So I'm not going to bother you too much about antennas, but just give you a storyline of what I've seen happening in the last 10 years. I wasn't there when Mark decided to acquire Cycleo, but I've been there for a long ride, as many of you know. And since a couple of years, I've been focusing on how to make things easy just on the antenna side. So first of all, let us realize what the fish is happening. Sorry for my French, but I can't use any words here. The hardware stuff is still the hardest problem that people need to solve. It seems, so says the analyst. And we as an ecosystem need to realize that 10 years ago, when I first entered this market, which was with a Sigfox head, can you imagine? The prediction was 50 billion devices. That never happened. Today we're looking at 12 billion devices. So something is wrong. Something is wrong with me, something is wrong with us. The market is there, the why is there, and we don't seem to be able to bring that together. Now, how does that come? I think for a customer, if I talk to my customers, and we have about 1,500 around the world, they always tell me, I don't know what to choose. You guys are all fishing for me as a customer, and there's too many of you. So I need to continue to run POCs, to de-risk myself, and see if I can catch the right supplier. And that's a bit strange, right? The market should be led by credible solutions, maybe in silos, and it should be clear what is the best solution or what are the best solutions in a certain space. But that's how the market looks at us, confusion. Then came the hyperscalers, which was very positive, because if a hyperscaler comes in, there must be a business. And we saw all those hyperscalers developing use cases and pushing the market in the right direction. But we also saw lately what happened when one hyperscaler disappeared again because of business reasons. They could make more money on the other side of their business. And when one hyperscaler bought a vacuum cleaner. I think you can read my comments or other people's comments on that on the internet, but I don't like a hyperscaler having a spy in my home. That doesn't sound right. So security, privacy, all that stuff comes back at us. And then we have the mergers. You just heard Mark and Julie talk about Semtech and Shera, and they can explain the strategy behind that. But we also have Thales and Telit merging and buying more companies. So at the end, what is happening here? And if I choose a supplier, who tells me he's not going to be merged or acquired or maybe even disappear at some point? That's not good for our IoT market. And last but not least, the sunsetting. This is a term that typically is being used in the cellular industry, and 2G and 3G, of course, are being sunset. We all know about that, but it causes great confusion and great despair for some customers who have been relying on those technologies. But also, we have the disappearance of Sigfox. We have things like WiMAX, Ingenu, on-ramp, weightless, all that stuff that has been there over the past 10 years. And all this together doesn't really help our industry to start scaling truly, because it creates this massive confusion and the next POC. Second, we have new kids on the block. There's an old radio here because I'm from an antenna company, and as you know, typically in the old days, you tuned your knob to find the right station, and that's how you found your station. And if you basically, sometimes you even needed to twist the knob during the transmission because there was noise on the channel. But that noise on the channel is something we create as an industry ourselves. Because what do? We start funding X number of satellite companies. And yes, there are use cases for that, but this is just an overwhelming choice. Again, I'm the customer. I need to choose between any of these. How do I do that? Of course, I can use some consultants to make that happen. And I'm not against satellite, but I think it covers only part of the connectivity needs. And for sure, there's not going to be 8 or 10 or 100 constellations. So that side of the market for sure will consolidate, which will result in other M&As and potentially sunsetting of certain technologies over time. On the other side, we have all kinds of new radio standards. We're just getting to the stage where LoRa and LoRaWAN are seeing some scaling. And I'm very happy to be back here after 3 years, because when I was first here, this is even longer ago, I think 2015, there was already a satellite and we had an old typewriter, remember? And it was typing these messages which were coming from a satellite. Today we talk about Matter. Matter is this new LoRaWAN layer for the smart home. If you ask me, you should put Matter also on LoRa, because then at least that ecosystem, our ecosystem, can penetrate that market too. Then we have the new radio standard for DECT. That's already in all our homes, because we use those phones. So why not use that for IoT? 5G and 6G. Let's not talk about reduced capacity, RedCap, which will combine under 3GPP release 17, the best of NB-IoT, the best of LTE-M, and then define a new standard. So if I'm choosing today to go with that technology of NB-IoT, I'm not even sure what's going to happen in 5 years. But my smart meters are installed and still there. So big risk. Ultra-wideband, I'm very glad to see that they focus on location, because that is a clear use case, and not so much on the data communication side. And then things like Vira and Wi-Fi 7. So again, imagine you are a customer and you have to absorb all this. I don't know, what the fish are we doing? I think we have to make it super simple. When I went to my kids and I gave them a box when they were 3 of Lego, I gave them the blocks, I gave them the little book, and they built their car or their house or their space rocket. It doesn't matter. They followed the steps. And we can only do that if all of us agree that we need abstraction layers between our little Lego blocks, but they all fit together. And we don't end up in discussions about co-op or MQTT or webhooks or whatever. I don't even know what all those terms mean, but I know they don't work together very well. And that's the same on the hardware front. Second, we need to move the complexity from the hardware back to the software, simply because there are 10 times more software guys than hardware guys in the world. And in my antenna world, there's only a very few who understand RF. So we are even in a more difficult space, because antennas are a difficult domain, and there's not too many people who truly understand it. Of course, in a bare board analysis, everything works fine, but that's not how the market operates. You got to squeeze your antenna into a casing, you got to put some batteries, etc., etc. Some choices will become easy. Sadly enough, I learned this morning that one of our partners filed for bankruptcy. That will happen too, so that makes it kind of easy if there's less contenders. So please make sure you pick your battles and you guarantee from your customers that they will roll out 50, 100, 1 million devices. So how do we make it easy? Again, we are an antenna company. We have components, you can see them on the booth, I won't talk about them, but they are non-resonant, so they're not really antennas. They can adapt to any radio standard. And if you ask me, if you look at the antenna market, there's way too many options. For those of you that make devices, you know that. You go to Mouser and DigiKey, you select an antenna for LoRa, you get 500 options. Which one is the right one? And which one doesn't work? And you can't test all 500. So at the end of the day, we believe that an antenna must be non-resonant. We only have very few, and we will make it work through so-called tuning. That tuning is highly sophisticated. You need complex software and some brain power. And the only way to resolve that from my perspective is if I give you the manual, my Lego manual, how to do it. We call that a cloud. At the end, you put your design there, and we'll tell you how you can solve your issues. And last but not least, please understand that any device that goes into the real world might not be in an ideal situation. We see too often that products work well in the lab, they go through certification, and then my grandmother puts the wearable on her arm for fall detection, and it doesn't work anymore. Yes, it transmits, but not far enough. That has to do with the RF side. And the same I can apply to containers. If you have container trackers that are mounted on the container with all the risks of damaging, fine, they face the satellite, and they can do GNSS because it's directional. If you put them on the side, most likely they're not going to see the GNSS or have difficulties in acquiring the signal, which means more battery power, which means shorter lifetime. And your ROI for your use case will be gone. Who here is a Formula One fan? I am. And I should have an orange shirt because I'm Dutch, but our marketing director decided that Egnion is red, so I'm standing here in red. And this is a story about Red Bull. Max does not win his races because he's the best driver. He for sure is a very good driver, but I don't think that's the only aspect of this. He wins the races because he gets all the options calculated during the race, whilst you are making your devices. And that's what he's doing. He's trying to overtake, he's trying to change the tires in less than 3 seconds. Oh, 2.1, Red Bull is good. Yes, but Ferrari also did it in 2.1. Who's going to win? And freaking hell, Ferrari makes the wrong decisions week after week. That's why they lose, not because Leclerc is not a good driver. How does that happen? That happens all in the cloud. They simulate continuously during the race thousands and thousands of scenarios to understand when to do what. And this is exactly how we want you to think about radio and about RF. I'll show you how we did it for TTN, because we have a generic node here, or actually two. At the end, Orkan, I don't know if you're here, Orkan, had some RF issues, so he went to our cloud, put in his design, and got back a recommendation. He started building his prototype, and he sent that to us, and all of a sudden there were 2 batteries on top of my antenna. Well, that's not going to work. So we went back to him and said, Orkan, we test your prototype, but could you move the batteries a little bit down? Sure. At that stage in the design, I'm just prototyping. Let me move them 5 millimeters down. Wow. And that really helped. That gave him 10% extra antenna performance, which translates in 100 meters more range or a couple of months more battery life. Then we built that device, or TTN built that device, and we got it back to test in the anechoic chamber, to test effectively, does that design that we recommended in the first place, that we checked in the prototype phase, does that still perform the way it should be? And I can guarantee you, from about 30,000 simulations that we have run, we can get you to about 95% accuracy from day one. The only thing you have to do is ask at the right time. Max doesn't go back to his Oracle Cloud saying, after the race, what should I have done? No, no, instantly, right at that moment. Box, now, change your tires and win. That's how we want you to think about the antenna side of your design too. Now, on the device here, you will, on the wall here, you will see several devices. Most of them are covered up, some are open. Check for that little red antenna. Here's an example of what happened in the real world. This is from Blues Wireless. I think they were presenting earlier, and they might have shown their device already. Here it is again. They came to us and had an antenna problem in the middle of the race. That was tricky, because we didn't know exactly how to fix that, and there are certain constraints that you can't change. At that point in time, they had a cellular variant and a LoRa variant, and you can see the blue band for LoRa, the blue area, is where they wanted to tune to the optimum to have the maximum range. And the antenna that they had on board showed a little detuning, as any antenna. That's okay, but you got to move that thing back. And that's what we are able to do with very smart tuning, again, in the cloud. You don't need to find it out for yourself. Just tell us what the problem is. We calculate and tell you how to do this, like Lego. The second issue, and we see that a lot, honestly, with 1,200 designs a year, trust me, I do more than 100 trackers a year. So our guys know a little bit about trackers. And they can tell you, if you go with LoRa in a 30 by 30 device, 30 by 30 millimeter device, with an internal antenna, you're not going to get range. It might be a very smart idea, and there might be a good market for that, but it's simply physically not possible. At least not with an SMD part. You have to use an external antenna or some customized metal stamp like there are in the Apple tags. But then you're going to pay a couple $100,000 to get the design done in the first place. What is a problem, not a problem for those devices in the field, is that they are positioned in a certain way. They don't always, you can't tell your customer you can only mount it like this or like this. Specifically in the tracking world, they end up everywhere. And they end up in pretty difficult places where RF doesn't function. So what is important, that you have kind of an omnidirectional radiation pattern. That comes in the reports, so you can see it for yourself. And last but not least, the same story as with the generic node. Guys, when you develop a device, think about your batteries and think about your casing. Because we can tell you there is an impact. And for those of you that are a little bit into these physics, 3 dB doesn't sound a lot, but 3 dB means that LoRa doesn't go 10 miles, but only 5 miles. Or when LoRa was doing 500 meters, then it's only 250 meters. I would like to thank you for listening to me in the first place, and I would like you to remember a few things here. RF is not in every design engineer's mind. It's a scarce resource, and if you have one, hold on to him, because there is wireless required to get your data from your device into your cloud. Make sure that you have tools, you can acquire them, you can buy licenses for that, to validate everything in an ongoing stage. Meaning, use the NXP or the ARM or the design tools from ST. Use all that to make sure that you optimize your design in cycles. And of course, I hope we can accommodate you by doing the same thing from the antenna perspective. This comes for free, so I'm not selling you anything here. You can play with it as much as you like, and you don't have to be Max Verstappen to use it. You can just go online and test it out. So with that, I would like to wrap up, and thank you all for your attention. I hope you learned a little bit about antennas. Thank you.
Yeah, go ahead.
Sorry.
Go ahead.
There's a cooking show. So if you're still hungry after lunch, or you want to know about antennas, our top engineer, Yolanda Kobo, is upstairs, second floor, second room, doing a cooking show with antennas, so you can see it all live. Thank you.
That sounds amazing.
Thank you.
Do you know when that is?
I think it's right now.
It's right now.
3:30.
Okay, so run.
Well timed.
Quick.
Thank you.
Thank you so much, Jaap. That was great.